Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. For decades, Jupiter's moon Europa has captivated scientists as one of the most promising locations in our solar system to search for life beyond Earth. We know it harbors a gigantic, global ocean, potentially twice the volume of all Earth's oceans combined, hidden beneath a shell of ice that is miles thick. But this shell is far from static. It groans, fractures, and shakes with events so powerful we've dubbed them Iceberg Quakes, or Cryoseisms. These quakes are fundamentally different from the seismic activity we experience here on Earth, which is driven by plate tectonics and mantle convection. Europa lacks hot, mobile tectonic plates in the terrestrial sense. Instead, its tectonic engine is driven entirely by Jupiter. As Europa orbits the giant planet, it experiences immense gravitational kneading. This phenomenon, known as tidal flexing, stretches and compresses the moon, generating staggering amounts of heat and stress within the icy crust. Think of taking a metal coat hanger and bending it repeatedly. Eventually, it heats up and breaks. The ice on Europa is constantly being bent by Jupiter's pull. This continuous stretching causes massive fractures, or lineae, to crisscross the surface. When the stress exceeds the strength of the ice, that tension is released in sudden, violent slippages, the iceberg quakes. These cryoseisms can be enormous, potentially releasing energy equivalent to magnitude 7 or 8 earthquakes on the Richter scale, far more powerful than the largest recorded ice quakes on Earth, which typically occur in glaciers and polar regions. The resulting seismic waves travel through the ice shelf, providing a unique diagnostic tool for planetary scientists. By studying how these waves propagate and reflect, we can effectively perform a subsurface sonar scan of the moon. For instance, the behavior of P waves and S waves tells us about the structure, thickness, and stiffness of the ice layer, and crucially, gives us definitive proof of the liquid ocean beneath. Perhaps the most visually stunning evidence of this dynamic seismic activity is Europa's chaos terrain. These regions look exactly as the name suggests. Areas where the ice has broken up into massive, jumbled ice rafts, often rotated and displaced, before refreezing into a confusing patchwork. These features are the result of intense ice tectonics, where blocks of the crust drift and collide, potentially over localized, warmer pockets of water or sludge ascending from below. The quakes are the auditory signature of this churning process. Detecting these quakes is challenging, given that no lander has yet successfully placed a seismometer on Europa's surface. The environment is brutal. Temperatures plummet far below zero, and Jupiter's intense radiation environment poses a constant threat. Future missions, like NASA's planned Europa lander, hope to deploy specialized seismometers, designed to operate in extreme cold and filter out local noise, such as the thermal cracking of ice due to sunlight exposure. Why is measuring these ice quakes so critical? The seismic data could confirm the existence of hydrothermal vents at the rocky core ocean interface. On Earth, these vents provide the chemical energy necessary to support complex ecosystems in the absence of sunlight. If the intense tidal heating of Europa's interior is causing volcanic or tectonic activity at its core, these vents could be feeding the subsurface ocean with the chemical building blocks and energy needed to sustain life. In essence, the rumbling and groaning of Europa's frozen shell aren't just fascinating geological events. They are the rhythmic heartbeats of a potentially habitable world. Every tremor, every crack, sends a message about the depth of the ocean, the warmth of the interior, and the potential for a thriving biological environment hidden miles beneath the ice. For more incredible facts like this, don't forget to subscribe and turn on notifications.